Happy New Year, everybody. Hope you all had a good holiday. So welcome to UX and Data. Tonight we're going to hear from Dan Huss. Dan Huss is currently the head of product management for the Project Pharos initiative within State Street Corporation. And prior to making the jump to State Street, Dan worked with Boston Consulting Group Digital Ventures. So please give a warm welcome to Dan.
Oh, hey. How is this? Can you guys hear me okay? Yes. So I have a joke in a minute about no one knowing who State Street is, but it's nice that JP Morgan's here, and maybe some fintech is here, and actually has some context around what I'm presenting tonight. So I have a little bit of a unique presentation style that I'm kind of testing out a little bit on you guys. So let's see how this goes. This could be interesting. So as Kim mentioned, my name's Dan. I run product at State Street Corporation, which it's a bank. It's the largest bank you've never heard of. As far as assets under management are concerned, we might be bigger than JP Morgan? Yeah? Question mark? All right. So I'm actually building an AI fintech product there. Pretty cool. And I'm lucky enough to have a few folks on my team in the audience who I've told to laugh at all my jokes. That wasn't one of them. Before that, as Kim mentioned, I was leading this same initiative, building this exact same fintech product with a company called Boston Consulting Group Digital Ventures. Digital Ventures is essentially an outsourced startup factory for large organizations. So I led product management here. We ended up transitioning this product into State Street just about 2 years ago. So while I'll get into this product a little bit later, I actually want to start our conversation today by talking about chlamydia. So this isn't some random PSA where I feel like really strongly about chlamydia and I have to do something about this before. This is also not some like very public and strange way for me to break this news to my girlfriend who's, before I wrote this joke, I did not know was going to be in the audience. So no, actually, it's about this video from Tom Scott. Do you guys know who Tom Scott is? One hand. So Tom Scott's an awesome YouTuber. Check him out. He runs a YouTube channel called The Basics. So Tom Scott described a time where his ex-girlfriend told him, over text message, to get checked. Pikachu emoji. So what did Tom Scott do at that point? Because he needed to get checked for an STD. He went to the clinic. He peed in a cup. And then he waited as instructed to then call up an automated line, enter his PIN that he's given, and ultimately he's going to get his results. So if you don't know, the general way that this works is that an algorithm goes and looks up your results. After the algorithm looks up your results, essentially a decision tree is formed. If you do not have chlamydia at this point in time, an automated voice then pops onto the system and basically goes, "You're cool, bro. You don't have any chlamydia. No problem." If you do have chlamydia, you then get directed to an actual person. So the thing is that this way that this machine works is interestingly instinctively known that there is a rule that if you're going to get bad news, you're directed to an actual individual. And this is probably because engineers, designers, whoever designed this system, at least put enough thought into it to know that bad news shouldn't be delivered by a robot. This is only one partially step worse than like learning you have an STD from a barbershop quartet, where my Family Guy friends at. So what actually did happen to our friend Tom here? So Tom called. He put in the PIN. The automated system picked up, asked him to hold, and then Tom waited. And then Tom waited. And he waited longer. After a grueling wait to find out if you have an STD, he finally got transferred to an actual person. Which we know the rule is, if you get transferred to an actual person, yeah, you have chlamydia. So a woman on the other end picks up, introduces herself, and tells Tom this. Nothing wrong. Tom did not have chlamydia. In fact, I'm pretty sure he probably wouldn't make a video where it ended in him having chlamydia. But he's mad because he just went through 5 grueling minutes of waiting on the line and then it immediately transferring him to someone where instinctively people know that that's a bad thing. So he asked the question to the woman on the other line, if I don't, then why did it put me through? Why did it put me through this? Her answer reflects a major problem with the way that we think about AI today. She said, I don't know. Kind of just does that sometimes. So for a few minutes there, an algorithm had immense control over how our friend Tom was feeling. This is actually pretty powerful when you think about it. The good news is that we don't actually interact with algorithms very much throughout our day, so it's not very much of a problem. Right? Ah, no! Obviously not! That was an obvious setup. None of you fell for it. We interact with algorithms literally hundreds of times per day. There's a range of how they make us feel, too. And that range goes from the accidentally cruel, as in the case of this chatbot, to potentially devastating consequences, as in this case, where someone didn't understand the limitations of the AI that they were interacting with, and all the way to potentially world-changing. Like the revelations that YouTube, Facebook are creating massive filter bubbles for us, so much so that it's literally influencing elections. The crazy thing here is that these interactions are actually only increasing as how people interact with digital moves more and more to 2 things, to voice and to chat. And they are. If you read anything about this, there are people who are now boldly suggesting that voice is the new user interface. It's not hard really to see why they're claiming that. It actually seems like the adoption of voice technologies and chat bots is even rivaling that of the rise back in the day of mobile interactions. Now we've got 27% of all internet users using voice technologies on their mobile devices. Further, there are now 100,000 different chatbots on Facebook. And it's actually even getting harder to tell if you're talking to a human on the other end of a chatbot line, so much so that we just got to see last year Google's demo of Duplex, right? Where you can place calls and try to set up appointments. By the way, this may be, if you didn't see this at Google's I/O, the first recorded instance of an AI actually passing the Turing test, which is pretty incredible to think about. So this transition from the visual to the auditory as a user interface suddenly changes the way that we, as product people and designers, need to think about our profession of design. We already think about this a lot, but essentially the emphasis moves even more or less on the well-formed and understood interaction conventions that we have today, and even more on what we already know to truly be true, where UX has always been, which is simply trying to answer the questions that our user is asking of us. So, if you buy into that concept that algorithms can affect our thoughts and our feelings, and you're also convinced that these algorithms are only going to increase exponentially as more and more technologies come out, then I present to you a fairly simple premise. Algorithms are going to exponentially shape our days, how we feel during our months, how we feel during our years. Effectively, the more interactions that we have with them, what we've designed starts to design us. Roll credits. Just kidding. So, as designers, thank you, my staff, for laughing at that. I appreciate it. Jeez, it's the fakest laugh I've ever heard. So, as designers, I propose a very familiar framework for us, the how might we question. How might we make sure that we don't leave creating algorithms to the engineers who are currently in charge of this? So before I try to answer that, which I'm going to go into via my product, Varus, which I'm developing currently, it might be helpful for us to make a couple distinctions. One, I want to talk about the difference between algorithm AI and machine learning. And I want to talk a little bit about how I get into thinking about just AI in general as a layman. But I actually don't want to dive like face first into this deep discussion of algorithm versus machine learning versus AI, because this debate is actually going on pretty extensively online right now. There's a lot of articles being written about it. And as a product person, I'm kind of starting to feel like shruggy emoji, like it might not matter that much for us. Although, when this question comes up a lot to me, pretty much this is how I start to frame it. So, for our purposes here, that wasn't one of my people. That's great. For our purposes here, I'm merely going to be drawing a distinction that I personally like, that I've done a little bit of research on, that I'm pretty comfortable with. And then after I draw this distinction, I'm not really going to touch on it very much because it doesn't really affect the rest of this discussion. And, but if I don't do this, there may be an engineer, AI fanboy in the audience right now who's going to come up to me after the show, bust my balls, worse than some Star Wars fan freaking out after The Last Jedi. So that's why we're doing this. So this is generally how I've learned to think about these. Generally speaking, an algorithm is a set of rules that when proper inputs are entered, sometimes, and I emphasize sometimes, even to the point that I used word art, result in a solution to the problem that that algorithm is trying to solve. Let's contrast that with machine learning, which does everything that I just said, but takes it one step further. Machine learning tries to answer the question, that algorithm that I just mentioned, how could that algorithm provide a solution when the inputs are much, much more broad, that it's had inputs that it's never seen before? That's the difference between an algorithm and machine learning. And finally, artificial intelligence, I think it's generally accepted now that for it to be AI, has to do the two previous things, but tagged on to that, it has to actually make some sort of behavior or decision. It has to do something with that data. So to sum this all up, algorithms solve specific problems based on rules and specific inputs. Machine learning allows those algorithms to expand it to new understanding of the inputs that it takes in. Oftentimes they're similar inputs, but it's an expanded view of those. And finally, AI uses that type of decision-making process to then go and generate some decision from that. Whew. All right. So, please, no fanboys. That's a quick and dirty way that I like to break down for the designers that I work with of how I like to make a distinguish between these, especially when we get into complicated conversations about nomenclature. I also want to take the time really quick to think about, again, as layman's, how we should be thinking about AI specifically. Data scientists. This is one of my actual data scientists. Probably won't like that I actually characterize data science and AI this way, but they can suck it. I found this has been fairly practical for product and design people when we're really trying to wrap our heads around what's actually happening. For us, we just need to think about this as complex statistics. How many of you were statistics fans? Yeah, cool. All right, I just lost the entire audience. So I'm going to try to break this down very simply then. So I want you to imagine for a second that you're this little dude. Aww. Aww. Yeah, good God, come on. And you're trying to learn how to catch one of these guys for the first time. At this point in your 5-year-old life, you've never caught a baseball. It's never been thrown to you, right? You're a 5-year-old, you've never caught a baseball. What's interesting, though, is that our brains have layers of previous information and experiences that help us to make predictions about things we've never done before. So this kid has never caught a baseball, but we got to start somewhere. So maybe this kid has an understanding of how gravity works. This is the first layer of understanding that can help this little 5-year-old catch his baseball. And for our purposes, I'm just going to call this the gravity layer. So this kid, also at this point, has some idea, even if it's not a baseball, about how a ball travels through the air. Could have been a football, like this poor little guy. But at least he's seen a ball travel through the air at some point. This is the second layer of understanding he can build on, what I'm going to go ahead and call just the motion layer. And finally, maybe this 5-year-old has actually held a baseball, so he knows its general weight and feel, but he's never caught one. So we'll call this the third layer. This will be the weight layer. So now, his dad throws him a baseball. What do you think happens? His brain uses the data that it has available to it, these 3 layers, to help him catch that ball. What do you think most likely happened to our 5-year-old? Drop the ball. Drop the ball. Probably got hit in the face. Let's hope he only dropped the ball. Why did that happen, though? Because his 5-year-old brain did a very bad job at calculating the probability of where that ball is traveling through the air, the trajectory of that ball. So let's imagine that this 5-year-old grows up, and he's now been thrown a ball a bunch of times. He's caught it thousands of times throughout his life, which is what we call practice. His brain gets better and better at calculating that probability of how that ball moves through the air. And ultimately, where that ball is going to go, so he can move his hand up and catch it. Artificial intelligence works extremely similar to this. What I just described, these layers of information, is what we call a neural network, and it's how AI makes decisions. It uses layers of training data, which, again, we would call practice. This data is the AI's practice to make probabilistic predictions about something that it's trying to do. That's it. That's all AI really does. Cool. So, when you realize that most AI is really just a complex way of calculating very difficult probabilities, it helps us as design people better understand, since it's probabilities, the challenges that AI has and how we design around it, like some of those very complex examples that we brought up. So, how do we start to better understand the information that, how we tackle these types of big questions? I'm going to go ahead and pause on my current fast-paced, clicking through various slides way, mostly because we're at 126 slides and I ran out of space to keep making these, and also I got a little lazy. So I'm going to pause here and linger on a few slides. The context in which we're going to discuss this is the product that I'm currently building today, which is State Street Veris. Not trademark, S-mark. What's the S stand for? What? Anyway. So State Street Veris is it's the first artificial intelligence application that my company State Street has ever launched. Let me tell you the background around this. We certainly did not start by saying that we were going to go and create an artificial intelligence application. We started the way that any good UX and product group would do, and we tried to understand our user. So we went and did many, many interviews. I personally probably did about 75 interviews. And we started to hear trends in all of those interviews. We heard this: I get so much information into my inbox on a regular basis. I get information to my Bloomberg terminal. I've set up email Google alerts for things that I'm trying to follow. I can't make sense of it all. I'm overwhelmed. And it takes me till 3 o'clock in my day just to make sense and actually get started on my actual job that I need to do. That was the first thing that we heard. It's become cliche, but this is the information overload problem. The next thing that we heard was very emotional. We heard these finance folks tell us, I'm terrified of getting stopped in the hallway as I'm walking to the, let's just say water cooler by our CIO or my boss who says, hey, did you see the latest news on the trade war? What's our exposure to that? And that person has not seen that news, or if they have, they don't have a very good answer to what's my exposure to that, because that's a very complex question. That's a hard question to ask, because they need to know what portfolio holdings that they're managing, assets, think equities, think bonds, whatever, are going to be influenced by this trade war. It's a complicated question. So there's this fear. We have information overload and fear. So we set out to go and try to tackle those problems. We had a period of divergence where we came up with a lot of different ideas to go and try to do this. And we had a period of convergence where we then began to consolidate those ideas into a singular concept. And this is the concept that we arrived at. So let me walk you through it. Veris is a mobile application, first and foremost, but really what it is a set of underlying algorithms that result in an interface. What it does is it ingests news content. It reads that news through natural language processing, and then through several deep learning algorithms, as well as just heuristic algorithms, makes a connection between the news that it's ingested and the holdings, think companies, Apple, Facebook, whatever, that exist within the portfolio that I'm trying to manage. It then uses another machine learning algorithm to determine the relative priority of those news items so that we can reduce that news feed, the 20,000 news items that are coming in every day, into just a small amount. What we wanted to do was solve that information overload problem, right? Give them a very, very curated news feed. The very next thing that it does is try to answer that question, what's my exposure to that? So we do that by then, we've got are first-degree connections through the natural language processing. If this article is about Apple, we know that it's directly about Apple. I hold Apple in my portfolio, and then I can tell that, I own X percentage of Apple. But that's only one part of the exposure equation. We also had to answer the part of indirect connections that might be further downstream affected. So if I own Apple, and Apple just announced last week, right, that its demand fell sharply, that's going to affect Apple's entire supply chain. So do I own someone in that supply chain? So this is important context to set up how we went and thought about developing this product and the 3 continual questions that we run into even today that we're struggling to answer, but we've taken a stab at it. Question 1. How might we as designers learn about and set expectations around AI performance? Who is familiar with that Tesla autopilot crash? Who read that? What happened was Tesla, the autopilot feature, the guy trusted it to make decisions, but what was autopilot doing the entire time that he was, I don't know what is actually happening, swerving in the other lane? What was the autopilot doing? Anyone know? Warning him! Put your hands back on the wheel, dude! This is outside of my parameters. So Tesla actually did a fairly good job of trying to set the expectations of what its AI was capable of, but it took this monumental crash for someone to actually get it through, right? You cannot just let your Tesla run yet. We are not quite there yet. We've run into our own, definitely not life or death version of this situation, but what we run into are these 3 questions. We are trying to reduce a news feed to the most relative and important things that portfolio managers and people who are managing a portfolio, think risk managers, care about. What does relevance mean? And who is defining relevance when we try to get those news items into our product? That's hard. Then, if we've defined this, what does it even mean to have an acceptable level of accuracy in terms of what that relevance means? It's a very difficult question. And finally, how do we help our users understand and then ultimately influence that relevance? So what did we do? Our very first stab at it was to establish this proprietary metric, what we refer to as the V-score. This serves a couple functions. So this is our primary ranking mechanism of the application. So you can see here, we've got some lorem ipsum in here on this screenshot. But we've got a 9.8, a 9.7, 9.5. It's decreasing as you go further down the app. So this V-score is to give you an indication of how you rank it. What's important about this is when you're designing AI, point number 1, you need to tell people when something is a prediction. There's a great post, 7 Great Principles of Designing AI, that does a very good job of this. But Amazon talks about this all the time. Whenever you see the "you might also like" column, it tells you why you might also like that. It tells you why they calculated that. And it lets you know that it's making a prediction that this is something, and this isn't human-generated content. This does a couple things for us. When we are not accurate, they go, cool, it's the algorithm didn't get it right. It gives us a little bit of leeway, because we expect way more out of human curators than we do out of an algorithm. So this was our first stab at telling people that this is being curated by machines and letting them know that that's happening. And any time as designers and product people that we have something that is being predicted by algorithms, it behooves us to do this. It's important to let people know when a machine is trying to predict this. Lots of good examples on this online. Check them out. The second thing we haven't launched yet is how do we allow users the ability to influence this? The most primary way that we do this or see this right now in the world is by like user ratings, Pandora style, thumbs up and thumbs down. That's possibly going to work for us. Our plan right now is to actually expose the components of the V-score and then allow people to adjust those weights. So this is no longer on us if their newsfeed sucks. You set those parameters, guy. So first takeaway from this is make sure you expose how, where in your application algorithms are actually making predictions. Second question. It's hard. How do we actually deal with error states and edge cases in AI? So when you ask Alexa something, and she doesn't know, she's got like 2 default responses? What does she say? I'm not sure about that, or I don't know that. There's no actual context around the question that's being asked. You don't know if she doesn't know that because that information doesn't exist. You don't know if she doesn't know that because she didn't understand you correctly. The thing is since algorithms are probabilities, she's making a probability assessment of what you said. And when you say something that she doesn't recognize, it fell outside of the probability that she knows what it is. How many of you have had Alexa respond back with something completely bonkers that you didn't ask her? She basically said, there's an 80% that person just asked me about clams, right? So I'm going to respond back with information about clams. That's not what you asked. You wanted to know about Christmas hams. I don't even think Christmas clams are a thing. So we ran into this situation in an interesting way, and possibly the most detrimental way. I'm showing a very old design because this was actually, we've corrected this largely. I couldn't find an actual new version where we made such a big mistake. So we make connections via our deep learning algorithm to holdings in your portfolio based off of what the content that's in the article. Here's a Volkswagen article about testing diesel fumes on monkeys. What's up with that, Volkswagen? This is a real article. We've connected, as a holding that exists in your portfolio, Sherwin-Williams Company. So there's a problem with this. We don't actually have insight into how that deep learning algorithm went and made that connection. So what we did as human beings, we looked through and we could not find a reasonable reason why Sherwin-Williams was there. Why this made sense that this was something that our algorithm connected to this. This is an error. You know what would happen when one of our users saw that? 1, we would lose trust. 2, they might go, what's going on with Sherwin-Williams and Volkswagen? And is Sherwin-Williams involved with monkeys? What? That's even a worse outcome than if they lost trust in us. What if they did something from that? So since they're based on probability, and often we don't have clear-cut error states, like when you're talking to a chatbot, like the example I showed earlier, how do you deal with this? Well, we took a stab at it, and this is going to be a theme that you see through pretty much the rest of this. We wanted to surface, and you're seeing the new design now, by the way. We wanted to surface in natural language why we made that connection. Because if we can show them why we made a connection, so here we have an article, whatever, it's about Qualcomm and Apple, and we have Skyworks. We can see that Skyworks is a supplier of Apple. Apple and Skyworks share the electronic technology sector, and something that we calculate, Apple and Skyworks share 3 underlying network connections. That means they share 3 supply chain connections. So if we surface this, and if this is bonkers and doesn't make any sense, it's much easier for that person to go back and say, wow, that truly is an error. Like, I'm not going to go make an investment decision on Sherwin-Williams regarding their testing their paints on monkeys because of this. So that was one of the main ways that we wanted to tackle this, is by being more transparent in how all of this is calculated. The second is where we as product and design folks need to start understanding how data science works. The reason that we're not seeing this as much is because we started optimizing for precision over recall. Precision might narrow that probability that we will see errors, like the Sherwin-Williams one. There's a trade-off, though, that we have to understand that that makes. And that trade-off is that we might lose a valuable connection. So as we narrow what we think is an acceptable connection, so let's say that if the algorithm is 90% sure that this is accurate, we said yes, we narrow that down to 99% sure, we're going to lose some possibly positive and valuable connections, but what also doesn't happen are false connections. So we moved to a precision model, and that was a trade-off, that was a product and design decision that we had to make, because that's something that affects our end users. It's not a data science decision. Lastly, how do we build trust? Use the trust word. How do we build trust in our algorithms? This is an important thing for us. I need people that use this product. People are going to pay us money for this product. How do they ultimately trust it? And this has largely been a theme of what I've covered in the last couple slides. But here's an example. Cool, you've got this V-score. How do I know it's working? How do I know that this is the most important piece of news for me today? Because you're telling me it's the most important news today by giving it a 9.8, when inherently news is going to be subjective. This might be the most important piece of news, this lorem ipsum news, for this crowd, but definitely this lorem ipsum news is not the most important news for my engineer, right? So it's a subjective thing. So how do we know that the algorithm is working? This comes back to transparency. This is a hard thing, and possibly the hardest thing to do when working with algorithms. Because in some cases, even the data scientists don't know why the algorithm is making the decision that it's making. If you were to go to look at AlphaGo, the Go playing Googlebot, people who played it described it as alien. And the developers of it can't go into its code base and say, oh, it moved this piece here because it predicted this. It just did it because we don't understand why, because it's been trained on billions of interactions. So transparency is critical. We did this through a not so great attempt at surfacing each component of the score. So we have three components, what we call the content component, the language component, which is of the language that's in the article, what is the most important. We have the risk component, of the holdings that are connected to that, what are the riskiest holdings that are connected to that, meaning what do I own the most of or has some other metric. And finally, network connections, how interconnected are the connections that we made to your portfolio. So we actually call internally this section score transparency. It doesn't do a good job. This like raises more questions than it actually answers, but this is our V1 of it. And we've got some pretty good thoughts about how we're going to cover this in upcoming sprints. So, last little thoughts. We have to work with our data scientists and our engineers to better understand how all of these algorithms work. Invite them, if you do design studios, to your design studios. Some of the best stuff comes from that sexy data scientist that I put up earlier who's single. He is actually so good when we go into a design studio. He'll sketch stuff up for us, and it results in mind-blowing, because they know better than anyone else how the algorithms actually work. When we're trying to provide transparency, they're the ones that can answer that question. So involve your data scientists and your subject matter experts who are helping to train these algorithms in AI in your design studios. It's so critical. The next is, in that video that I started with Tom Scott, who is a computer scientist, but I'm not sure necessarily understood product development when he brought this up. He said that this is an ethicist's problem, that this is we need to bring ethicists into the way that we do computer science and algorithms. And ethicists are going to help inform us as product and design people about how to help us make these decisions, but they don't run usability tests. They're not going to be able to calculate all the edge cases. They're not going to basically understand what it is that users are thinking in key moments of their life when they're trying to make decisions. So the responsibility falls onto user experience people to start to better understand data science and understand how algorithms through voice, chat, and other user interfaces are affecting our lives on a day-to-day basis, because none of us want to be in a situation where we're worried on the line for 5 minutes about chlamydia when it turns out to be nothing. Thank you all.
So I think we have some time for questions, but please wait for the mic before you ask your question. We'll have 2 mics, one on each side of the room. So if you've got a question.
Hi, so you mentioned that you had some thoughts about how to improve the transparency for your score component system. I was wondering if you could elaborate on some of those.
Yeah, definitely. Let me actually just go back so this isn't on the slide that says chlamydia. So we took, when we started developing this, so the question, I'll just reiterate, was he asked if I mentioned that I had some thoughts on how to add more transparency into our algorithm other than the current iteration. When we approached this, we tried to overly bucket this. In fact, I might even say we overthought how this needs to be. We wanted it to be simple. Honestly, when we originally designed this, we tried to MVP this. We didn't actually know how to answer that question. Now we better know how to answer that question. We did a design studio with my data scientist and the rest of my team. And what it turns out is that I can pull up individual ways that this is actually calculated for the most part and surface those in natural language. So let's take maybe just this piece as an example. So the content component of our algorithm reads the words, what we refer to as entities in the algorithm, and then it makes a decision based off of a machine learning algorithm that has been trained from subject matter experts on 15 years of financial data. So what that means is our subject matter experts have gone through and said, this article has high priority language. So we said content component, and we were able to normalize a distribution about how between these 3 components it was calculated. What I would like to do instead is what is actually happening, where we say the language in this article holds an 80% probability that based off of 15 years of training with subject matter experts, it's high priority, or medium priority, or low priority. So we want to surface the actual way that we're calculating this. As I mentioned about with things like Google's Go playing AI, you can't always do that, and it's actually very difficult. But in these circumstances, we can.
Hi, you mentioned that you made a decision on the product level about optimizing for precision over recall.
Yep.
I'm not really understanding what you mean about recall. Can you explain that a bit? And then also, can you talk about how you came to that decision? Did you test with users, or how you arrived there?
Great. So the question is, how did we arrive at the decision to optimize for precision over recall, and how did we arrive at?
What do you mean by recall exactly?
So recall is our algorithm's ability to basically recall all things in a set. So if it's going to try to make a connection from a news story about Apple, and it recognizes Apple in that story, but let's say that that post was written by an analyst at JP Morgan, and it was a tiny little footnote at the bottom that it was written by an analyst at JP Morgan. The article is not about JP Morgan. It's not necessarily affecting JP Morgan, but machines don't know that. It just sees the words JP Morgan, and it picks that up. So do we allow it to expand and look at all the entities that it's pulling out? Do we allow it to recall all the entities that it's connecting to? Or do we try to narrow and reduce essentially the statistical significance of its set? Does that answer your question?
Yes.
So if it said JP Morgan, this article is 90% likely about JP Morgan, we would change that from a 90%, and we allowed it to surface that. We changed that from, okay, you need to be 99% sure that this article is about JP Morgan, and it would cut it out. And like I said, we might miss a few things, but it's worth the trade-off. We made the decision because for us, building trust, to show a horribly incorrect connection is substantially worse for us than to show a possible missed connection.
Did you do a lot of user testing along the way?
Yeah, so we talked to our users at these early stages when we were going through this process, probably about every 2 weeks. We run into a situation where our organization, and this is probably true for a lot of you, guards its clients in a B2B situation. So it's not always easy for us to get in front of them and put this. We've been lucky enough to have access to a few of them throughout the years who have been extremely friendly and help us through the process. And then we just do surveys, other things, and most people are pretty responsive. We also recently had a lot of success with Respondent. If you're not familiar with Respondent, my lead UX designer turned me onto it, and it's awesome.
We have a question back here.
Is this on? I'm going to be one of those people that makes a comment instead of a question.
Oh,
Sorry.
no!
But I don't know, it strikes me as interesting that this idea of transparency that you're talking about seems very particularly relevant for this exact product, that it's a decision-making tool, potentially very important decisions are being made here. And so having that kind of, and I mean, similarly, your medical health example makes sense as well, that you really want as much transparency as possible. But it strikes me that there's probably many, many products out there where this level of transparency would be unnecessary, would weigh down the experience. Like, do I need, when I see something in my Facebook news feed, do I need to see all the information about why that's appearing there and all, what's going into the algorithm to put that there? So it's just interesting to think about the different types of products that would really benefit from greater transparency versus when it's unnecessary.
You need to see how Facebook is calculating what goes in your newsfeed. Probably more than anything else. You need to see that you're seeing an article because you clicked on some other article. Facebook, it's on them to make it very clear to us why they're surfacing the information to us, because it is having massive impacts on the way that we live our lives, and it's shaping how we think and we feel in the case of filter bubbles. So if you're driving your own filter bubble by clicking on posts that support white supremacy, and then all you see after that are white supremacy posts, Facebook needs to tell us that it's because you showed an interest in white supremacy. So I would say it's extremely important in those situations. And we see it a lot in way less dire cases. Like you see it a lot in CRM systems, and customer service systems. I would recommend a post, I mentioned it once before, seven design principles for AI, I don't know, I forget. Something like that. Google that, you'll find it. There's literally 4 posts talking about AI and UX. You're gonna find it. So the author of that post talks a lot about customer service and how it says predicted importance of this customer issue. And you can imagine why showing that, it's important to say predicted importance of that issue is important for a human to see it.
Thank you, that was great. Any thoughts on the user validation aspect? So if you have a prediction that's inaccurate, irrelevant, is it just as simple as kind of vote up, vote down, or do better?
For our product, it's not. It is not as simple as that. We have folks who are, as I mentioned before, part of their mental model is this fear of missing some sort of connection. And while I will say we do fully plan on giving individual personalization towards this, if we were to allow complete personalization, thumbs up, thumbs down, we're going to create that same news bubble. And our user told us that they're afraid of missing something. So if we only tailor news to them and connections to them, we are doing them a disservice. So we have to walk a fine line from how do we provide personalized news that they really care about to staying within our true value proposition. So that's how I would think about it for our product. It's going to vary. There's other ways to train it.
Hi, over here. I'm in the back.
Where?
Yeah,
okay,
right
I see you.
Hey. So this is maybe a kind of abstract question here, but thinking years into the future, is there a concern that this might affect the way people write articles?
So, yes. And I'll give you a very clear-cut reason why. People completely changed the way that they wrote articles already for an algorithm. What am I talking about? Talking about search engine optimization. And when they could, back when Google didn't punish this, back in the early days of trying to get your article ranked, what did people do? If I had a keyword, what did I do with that keyword? I had invisible keywords stuffed into the article, hidden in there. And Google caught on. So it's already changed the way that people are writing articles. And algorithms make decisions even today on Facebook and other places based off of engagement metrics. So if you write an inflammatory headline, and even if it's not true, and it gets engagement, it's going to get boosted. So we have to be extremely careful. And we need to, more than ever, rely on independent and trusted sources. And there has to be, this goes back to the Facebook, like they have to do something about this. Other questions?
Thanks,
Here it
Dan. That was
comes.
awesome. And I also really appreciated your team that would totally pass the reverse Turing test where the robot would think the human is a robot. I have a question about user validations, or actually just validations in general. And I think a lot of designers in the audience might resonate with that. Like when the way we seek validations is by A/B testing or multivariate testing. Do you see a case for a way to remove the unconscious bias, which is very human, by utilizing maybe an A/B AI peer learning algorithm where the AIs are learning from each other?
So if I'm getting you, Ivy, are you asking, so your question is, are you asking about can we automate A/B testing through having algorithms communicating to each other? Or can we create AIs that will remove bias from each other?
The latter.
The latter. So like, can we A/B test with, can we like try to program an AI that will eventually remove its bias? Wow, that's heavy. Not being a data scientist, everything that I've read suggests that that's essentially a possibility. But all artificial intelligence is built around a data set that would be ingested into it. So that very first data set would have to be still very well cleaned by a human. And then you could train the other AI based off of instances where like it's punished for exhibiting things that we've deemed as bias. But as we've seen, when we pull large data sets from places like Twitter, we get AIs like Tay, who are evil. So we got to make sure the data set is correct.
I had a follow-up question to the question about the thumbs up, thumbs down, and just kind of getting feedback from users and how that is affecting machine learning, and how are you incorporating machine learning, supervised learning, maybe, into kind of how the algorithm performs over time?
Yeah. So this score here, one of those components, as I mentioned before, was the language score, or the language that is made up from it. We had this hard question that I posed somewhere around this slide on news is subjective, and we could rank news items in any way and potentially be wrong. So we had to ask ourselves, how do you calculate relevance here, right? Well, for us, we used supervised learning. We have subject matter experts who are former CNBC expert journalists that focused on the financial sector, who, as well as risk professionals, who then go in and on a regular basis do supervised training to indicate whether or not something is a high priority article or not. It is significantly more complicated than them going up and thumbs downing and thumbs upping things. But that is, you could imagine that this is our subject matter experts playlist right now. But that's only one component of it. There are other non-supervised learning components of it.
I have a question on the topic of transparency.
Where am I looking? I lost you.
Same area.
Ah!
Just right. Topic of transparency. How should we think about how much level of information to expose once we make the decision to be transparent?
Oh man, good question. Like, I was literally talking about this today with folks on my team. We reach a point where if we expose too much information, people realize that they're not data scientists and this is, what are you doing? And it's just too much information. It's not going to help them. So you can reach, in my opinion, a point where you've overexposed them to how it all works. I would say you give them just enough information that satisfies the fear or the curiosity that they have. And that's only going to come through careful user testing. I know that within the application that I showed you here, not a lot of people are scrolling down to that score transparency area if we look at user behavior. And it's probably because it's not providing them a lot of value yet. It's not really answering that question. So when we go on to the next version of that and surface additional information around that, my big question is, are we going to be providing value? And do the subjective questions that we send out in our surveys around, do you understand how this is calculated and do you trust your algorithm? Do those KPIs go up after we've changed that?
My experience with tools like this that are designed to enhance personal effectiveness, for a group of internal clients, is that quite often there's a honeymoon period where everyone's using the tool, everyone's excited about it, there's a lot of buzz, after which interest wanes. And then it never really is used to its full potential. And I was wondering, what type of internal marketing do you have to ensure that it stays top of mind? You're keeping it relevant, you're keeping it refreshed, best practices, et cetera. And then how are you measuring success? By the total number of users or the depth of engagement within a smaller group?
Have you been talking to my clients?
Not, no.
Yeah, what you described is 100% accurate. I hope there's no State Street people here. We have not reached product market fit. So we're all familiar with the term product market fit. In my opinion, we have not reached product market fit. Our true target user has actually indicated to us that this is providing a lot of value to them. Now we really need to find many, many more of those target users, our early adopters, because we did have a little bit of a honeymoon period. But we also have some users who use this substantially throughout their day. So I'll get on to some of our KPIs and how we measure success for this in just a moment. But we have a very, very strong hypothesis about what it's going to take for us to get to product market fit. And I'm pretty confident that if we continue to go build those features over time, that eventually, we're going to get through what you just described as the trough of sorrow, just like any other product gets, right? It doesn't matter that I'm in an enterprise environment. We're in the product trough of sorrow, where we launched, had the TechCrunch bump. For us, we got all sorts of press, a lot of excitement, but we need to go continually talk to our users and build the features that they want. And I have a strong hypothesis about what those are. I could be wrong, but I'm pretty sure. We've talked to enough users now. To answer your second question, how do we measure that success? We do have a very strong ability to go and advocate within the business development department, the relationship managers within our organization, who are a huge fan of this. Because do they want to go talk about custody? Or do they want to go talk about the cool new AI mobile app? They want to go talk about the cool new mobile app. You guys don't know what custody is, but it's very boring. So they're happy to go talk about this, which gets us continued traction. I'm not going to wake up one day and officially know that we're at product market fit, but we measure daily active users just like anybody else. My personal kind of benchmark for this is when I talk to them and send out surveys, and 40% of my users say something after we ask them the question, would you be sad if we took this away? Would it affect your daily lives? And if 40% of my users say, yeah, please don't take it away, I'm going to feel pretty good about that. And that'll indicate to me that we're getting closer to that product market fit level. We've got a couple other KPIs, standards.
All right, time for maybe one or two more questions, if there are any more.
Yeah, I love the presentation, by the way. Very good.
Thank you.
Very engaging. So I'm just kind of wondering, typically in investing, there's like fundamentals versus trends. See, and I'm just wondering how you're gauging that, because, depending on where you're coming from, right? And this really goes to the idea of those sort of filter bubbles.
Yeah.
Right? Like, you can have something, like, for example, Amazon went on for years not earning anything, but it had that hype that kept it up, right? And is that something you guys deal with?
Yeah, so if I could paraphrase that question. Different hedge funds, asset managers, asset owners that we work with have different approaches to the ways that they do their investment models, right? Oftentimes those are referred to as strategies, right? They're their corporate strategies. And how would we address that within the application? This comes down to a couple different things. You'd mentioned trends. Right now, the algorithms are very good at dealing with company-level news, equity-level news. So that allows us to basically cover equities and corporate bonds. Up until recently, the algorithms were not particularly good at handling things like macroeconomic news, so trends. So if one of our clients wanted to ask the question, oh my gosh, I just saw crazy news about new tariffs, what's my exposure to that? Right now, our algorithm would go, you're connected to Apple, you're connected to Microsoft, and the answer is no. Yeah, this affects my entire portfolio, right? So it's not going to do a good job of surfacing that. We're launching, Wednesday, Saturday, a release that we have a work stream called Macro that is going to do our best. It's our V1, our MVP, of trying to answer this question around trends. The second part of it, which is about strategy, company strategy, when I talked about how we want to involve someone in the customization of this score and being able to turn the dial up in weights on certain things that they cared about, if they care about fundamentals over something else or other risk metrics that we've been able to surface, maybe they just want to see their top allocations, so they crank up the allocation weight. We're going to give them that type of control. So they'll be able to, we are not going to be able to build algorithms yet based off of each individual strategy. But what we can do is allow them to customize the ranking of this and then see contextualized metrics that we surface based off of that. Cool.
Great. Thank you very much, Dan.
Thank you. This was so fun. Thank you all.